What's up, what's up? I am busy on my phone waiting and watching. I'll tell you what I'm doing in a sec. It's just that the time is nigh and I want to see if I can get this frame perfect trick. No, I'm joking. I'll tell you guys what I'm doing in a sec. I'm waiting for something to happen. And then when it does, I react. And then we see if I was successful. Well, I could be waiting for a few minutes. That's the problem with this. I wouldn't know. But let's see how it goes. So, I'm on the Pokemon Go Discord. And in Pokemon Go, every Pokemon has a number, a single integer that kind of represents its quality. It's just a kind of measure. And so, because this number is so prominently displayed in the game, the Discord has made a kind of channel where we're posting these Pokemon one at a time, incrementing that number. And so it ends up being a case of, oh, okay, if you have a nice Pokemon you want to post, you wait for your number to come up, and the first one that gets posted is held. And so according to those rules, we build numbers one after the other, and anything that was not posted, if you post the same number twice, the later ones get deleted. And if you post, if you skip a number or something, then it gets the log, so the list of all of these things gets reverted up to the point where it broke and you start again. So you realize what I am describing is a consensus algorithm, right? It's exactly the same as what I'm doing at the moment in code, except we're doing it as people. And so I aim to be the fastest server to post 717, but it's currently at 715, and so I'm just waiting. I'll load this up on a desktop browser just to show you guys what I'm talking about. Fucking desktop browser needs to fit on the right side of the screen. I don't know why it changed. Go. I think I got it. Yes, I got it. So as soon as I saw 716 pop on the screen, I just went in. This seems to have been uncontested, so nobody posted the same thing after me and then got deleted. But I had to be fast just in case there was competition. So I'll show you what I'm talking about. Here it is. 715, 716, and just off my phone just now I posted this derpy coughing photo. It's a slightly enlarged coughing is what that is. And I got a dash react. Fair enough, why not? Yeah, so that's all that I was trying to do. So, okay, I don't need this phone anymore. Let me turn off mobile data before it gets used up. Yeah, this is just something that happened today, and so it's taken up a lot of time today when people are trying to post the meme numbers, like see, it's going to be 718. So people are trying to post the meme numbers like 420 and 666 as well, 404 and 314, 1337. I'm sure is going to be one. Did I see a cat? Was that a cat? I don't know what that was. But yeah, as you can see, the log is continuing to build. 718, see that's 7, 6, 5, 4, 3, 2, 1, you know, this perfect log that's just built by people posting in instant messages. And so every time there's a problem, you know, it gets reverted. It gets, you know, updated by, I guess the role of the leader here is the mods, the people who have the privilege to delete photos. Yeah, you can just see it. You can just see it there. And so where, you know, it's gone to the point where like 20 things were posted, but because there was a mistake, it got reverted and fixed up. Cool. Anyway, that's the first 5 minutes of the stream, just me talking about this shit. Nothing much to look at here other than yeah, it goes all the way back. I see. Did you see this? So 725 just got posted, despite the fact that we're on 7.2. Oh wait, no. Sorry, 728 got posted, even though we were supposed to be on 725. So we have another 725 here that arrived after this one, and so that's going to get deleted. It's gone 726 because we've had because of internet lag. So it's like some of the servers are slower than the other ones, and so they post entries much later into the consensus, and those then get deleted. So the faster servers have precedence. That's not how Raft works. Raft is all about following one nominated leader. But I don't know. It's just a fun analogy, I think. I thought it was kind of cool when I saw this happening, and so this channel, it stretches all the way back to 10, which is the smallest possible CP in this game. So CP is that number. Yeah, so pretty much. That'll continue. I mean, I'm streaming now, so I'm not going to look at this for a while, but I'll see if I can post some other fun numbers later on. Yeah, good shit. Alright, let me get myself organized then. So I want to start the actual work that I was doing. So I need to, first of all, I'll turn on the back in 5 minutes text, because I need to go and put this phone back. I think I have, yeah, let's pretend I've taken a piss. I don't actually remember, but either way. What's that? Wind Waker HD, any percent. Okay, well, you have something to watch while I'm gone. What's up? Yeah, I'm ready to go. I'm a bit nervous with my bladder today. I don't know why. But never mind. Let's actually get started and do some work. Am I happy to stay in this position? This position's a bit. Usually I'm sitting back against my bed, but I've kind of crouched forward a little bit this time. I don't mind this position. It's just a little bit. I'll tell you what. I'll rejig my camera stand slightly so I get a better webcam angle, if that's at all possible. Oh god, this is slightly harder than I thought it would be. Come on, fuck, ow, dear lord. Okay, one more. Ding, got it. All right, cool. Whoa, bloody hell. Camera goes up, points at the ceiling. Alright, okay, so I'm going to set my camera. I'm going to sort my camera out, and then I'm going to be ready to start. Also, sorry if I accidentally nudged the microphone a few times there. Whoa, that's a big face. Go back. To like here. I'm going to lean back slightly, so this is not easy to set up. Do you know, a problem I've always had with this camera is I can't tell which direction focuses it in which direction in a real sense. So, okay, if I move my face forward, I have to twist it anti-clockwise to get it focused, right? So now I move. So I'm twisting it anti-clockwise. That means that back here, oh, it's out. Oh no, I got it the wrong way around. So here it's really out of focus, which means that twisting it clockwise increases the focal distance. Is that true? Well, see, it's still really out of focus, but now if I twist it clockwise, it's really out of focus up front, but if I go back, it's, whoa, even worse. Okay, so I've got this wrong. Anti-clockwise is... Man, I quit. I do not have a clue which direction corresponds to which direction. Do I just do a stream like this? That would be fun, wouldn't it? Nah, fuck it. I'm gonna, because I don't want to crouch too far forward, so I'm gonna... My standard sitting position is going to be kind of like this. So let me try to just get it right from there. Come on. So I want to twist, to get it back, I'm twisting it clockwise. I know, I'm aware the lighting is pretty naff at the moment, but I just kind of can't be bothered to put too much effort into sorting that out. Is this okay? Yeah, I think this is okay. It's a bit tilted to the side, unfortunately. But I'm not sure if I can really do anything about that. That's about the position of the bed. That's pretty flat. Yeah, sorry, usually I'd set this up before I started streaming, but I wanted to capture myself. Well, because I was wasting so much time waiting for that, like, the messages to come through to the position that I wanted them at, that I just decided to go like, okay, I'm just going to start streaming anyway and see how it goes. Yeah, never mind. Okay, this is all set up now, I think. Right, so camera, let me just chuck you in the corner. Streamlabs. You know, left, right, camera's working, microphone's working. Good. Okay, oh god, 12 and a half minutes in. Sorry guys. Let's start. So I am busy with Raft. What that means is, well, okay, you can see a quick catch up of what I'm doing and what I'm doing next. All that stuff is now on my Twitch page, just below the stream. So you'll see, like it says, you know, the story so far, I'm debugging part B, which is about transferring data through the algorithm. And what I'm doing, what today is going to be about, is quite specific. So the bug that I'm going to be dealing with, it's not even explicitly a bug as much as it is that my software is kind of fundamentally dysfunctional in a way that I am kind of scared I'm not going to be able to fix easily. So I'm kind of worried I'm not going to have a way of figuring out a solution, right? Because it's kind of, yeah, it's really out of my depth. I'll show you guys what's going on. So let's, okay, starting, so I've loaded up my IDE, I've loaded up the session in the terminal, and now I'm just going to run a test. So it's going to be 2B1, the first test of part B of Raft, and I'm sending that straight into out. And you know what, I'll put a chat message in saying, work starts now, XD, XD. And there's a ding, which means that everything is working on my end in terms of my chat. And so if people want to chat, they can say some words. Left, right, mic, okay. Cool, so we have here the first test of part B. And, you know, it's been failing pretty systematically the same way. You see how it says 1 brackets 100 failed to reach agreement? What that means is, because it's not, the testing isn't all that well documented, what I think that means is that one of the data entries in the algorithm, namely 100, so 100 is the entry, that entry consensus was not reached, it didn't succeed. But this test is dependent on RNG, right? Camera, mic. Actually, yeah, I just wanted to check that I'm in the right place on the camera. Yeah, I'm fine. That's cool. Yeah, the testing is dependent on RNG. Because this is a distributed system and things get executed out of order, and there's some inherent randomness in how that's done. Pseudo randomness, sure, but you take my point. And so I get different results every time I run it. So you can see in this case, nothing, the 0 at the end means what is the commit index. So it's the index of the last thing that's been committed. And if it's 0, then that means that only the 0 thing has been committed. But in principle, the 0 thing is just a dummy placeholder variable. This isn't an actual command. So this is the thing in the 1 position in the log. This, I should say, is just the log. 1 is the term. 100 is the actual entry. And so when it says 100 failed to reach agreement, that means this entry was not committed by everyone. So you can see that it was committed probably by the leader. It wasn't even committed by the leader. So you see the 0 number is the commit index, and so if it gets committed, it should be 1. But nothing has committed it. I'll tell you what, just to prove my point, I'm going to do another quick... I'm going to redo the test, quick, fast. So we'll get a different outcome. Hopefully there'll be some commits that have happened, and so we'll see the number 1 a few times. And that'll show you guys what I mean by it being a bit random. No, this time it was even worse. The thing didn't even get written to the log, so all the logs are empty. This time was particularly bad RNG. Let's try it again. I should say the best outcome I've had with this is that the first thing got committed, right? So 100 actually did get committed by everyone. And so the error was 200 failed to reach agreement, implying that 100 did succeed. And so the best I've done with this test is that I've managed to get 1 entry committed, even though it's trying to commit, like, I don't know how many, just a few, not that many. But yeah, I'm on a sort of, on a scale of, at best, 1 entry got committed, and at worst, like, the entry didn't even make it past the in phase of the algorithm. So it didn't even enter the algorithm. So here, for a few times, I've just had empty logs all around. Okay, so a quick summary of why this is happening. Well, we can go through the log and read through all this to try to figure out what happened. The thing you'll notice first is the fact that, this test is designed to be relatively stable, I think. But it says here, this is the term of each of the servers. And an election term is increased every time a new election is called, and then it's synchronized across servers when they send and receive messages from each other, between each other. And so the fact that it's on 10 means that there were 10 elections. And, if there is no leader, then the input phase of data entering the algorithm, that fails because there is no leader to pick the data up. And so that's how quite often we don't even manage to get the data in. And I can show you guys vividly that happening because I have inputs. I can control F the word input, and input triggers every time the external thing that's using the Raft algorithm that I'm using, so like the tester, say, every time that tries to send a piece of data in to the algorithm, X is given if the thing is not, if the server, namely server 1, from 0 to 4, in this test there are always 5 servers. If server 1 does not, is not leader, then it will, if any server is not leader, then it will write input X, as in I was a follower, so therefore I'm ignoring this, because in principle the leader should pick it up. But if there is no leader, then you'll find that this happens. All of them reject the data. And so input, it says here 1 of 30, but if I type input X, it just also says 1 of 30, because all the inputs failed to come through. If I type input O, then that means that something actually did get picked up. So I'll rerun the test and see if we have an input O, for example. Every time I rerun the test, I guess I get like a different seed. So I get different a different outcome. And see if I can scroll back here. We actually have a commit here, but the commit was not synchronized or syndicated even to any of the other servers. So 1, 2, and 3 have not read the commit. I think 4 must have been the leader. 0 here has also quit. The piece of data has been written in all their logs, which means it was about to be committed, but the test ended because, haha, you're too slow, effectively. I can't be bothered to imitate Sonic the Hedgehog. But yeah, basically, the fact that input is O, see 4 here, picks up this piece of data in term 3. And so that piece of data ends up, data, term. So the term is 3 and the data is 100. That ends up in all of the logs of all the servers. But as you can see, there are lots and lots of input X's. And in principle, yeah, see here for example, this 2 bouts of not a single successful input, and then in the 3rd bout, 4 actually did pick up the input, and then immediately rejected it. Oh no, this means there's a bug in my code. Sorry, I'm printing inputs X in addition to input O. I know what that is. That's just me failing to do an if statement correctly. I can fix that. Basically, yeah, this should be else, because I only want this to print if there was a fail, on isLeader. Yeah, so that's an easy fix. So this sentence wouldn't have appeared, so I'm just going to delete it, fudge the log slightly. But my point stands. Like, this is already at the end of the test. This input O here is the last thing that happens. After that, it's going to try to input 200, but the test timed out, and it's timing out because there are so many unnecessary elections. Actually, in this case there are only 4 elections, but it's still just so slow for some reason, and yeah, it's kind of difficult. Maybe the data's not getting sent out. I should definitely, actually, just as another point, I should log the fact that data is getting sent out, and the function that does that is in Raft flow. I think it's called apply entries, and yes, I'm going to just write down a print statement here. rf.me apply output even, because this is the output phase. And the thing that it applies is just I'm gonna just go ahead and put down the index rather than reading the actual entry, because I think reading the entry is unimportant. So yeah, rf.last applied. That's the index that's tracking what was last output by the this particular server. And so I'm going to increment that and then put the print statement in here. And so we'll be able to also see if there are outputs. Doggo is balking. Yeah, so anyway, it's really not working. But why is it not working? I think it's because there are tons of unnecessary elections. It's kind of the point of the leadership cycle is that server is a follower, but it has a timeout, and in that timeout, either it times out and then becomes a candidate and throws an election, or the timeout gets reset by receiving a message from a leader. So this is just the basic election cycle. And then if it is a candidate, it calls an election. If it wins a majority, it becomes leader and sends out messages as soon as possible to try to subdue all the other followers. And the problem I'm having is that, like, the leader's not sending out these messages, these heartbeats, fast enough, and so everything is continually triggering elections. And the way the code is structured is, if an election is triggered, the act of requesting a vote is going to reset the leader, because elections triggering increases term, and the thing that has the newest term always dominates and sets the other server to be follower. And term basically is who should, if something receives message from something with a higher term, it acts on it, or a equal term. If it's a lower term, it disregards it. So term very much dictates how things happen in this algorithm. So yeah, it's going to be a question of, you know, figuring out if elections are happening fast enough, if we're continually getting like failures, sorry, re-elections and that kind of stuff. You notice, by the way, I've just done something interesting here. I've Control F, so I'm looking for a question mark, and the way I've designed my print debugging, a question mark gets printed if and only if an RPC, so a message from one server to another, times out. Either the send or the receipt doesn't happen. As in, sorry, either the send of the RPC or the response from the thing that received it back to the sender. One of these doesn't come through, then a question mark timeout is logged. And so what this means is that if there is no timeout in the log, that means that everything is stable and all the servers are able to communicate with each other, which means that, you know, it's all my own fault, basically. It's a perfectly stable system, but things are not happening fast enough. Maybe there's not enough parallelization. Maybe I need more cores, processor cores to be running the code or something, or I don't know. But basically, the kind of thing that's happening is very much like just the camera and microphone periodically, and check that I'm still alive because my internet cable unfortunately does fall out sometimes, which is, oh god, so scary. It's fine now, but like seriously, I'm just kind of worried. Actually, yeah, I'm gonna just do a little bit of rejigging to make sure I have some slack in my internet cable, because if that comes out again, I will be pissed. Just a little, yeah, it should be okay. I'm calm, guys. And I guess, okay, I'll take a quick moment to refocus the camera as well. Hi. Was listening to some Dilla joints yesterday. One of them is called Hi. It's like, hi. Donuts is a pretty good album. You know, not saying pretty good album. One of my favorite hip hop albums, Donuts and Paul's Boutique. Both of them just for the sampling. Sampling is really, I think, the coolest thing about hip hop, as well as to an extent the rhythm. But the rhythm kind of camera mic, yeah. The rhythm is better demonstrated when hip hop is appropriated by other genres. So like when jazz picks up hip hop rhythms and that kind of stuff. But in pure hip hop, I don't pick up the rhythms as much, and it's more kind of the sampling that interests me, just personally. Maybe that will change in the future. It's a very weakly held opinion. Cool. So listen, yeah, I want to demonstrate the kind of thing that I've been talking about just by flicking through the log a bit. So, you know, everything starts out as a follower, and because there's no leader in the beginning, all of these inputs fail. That's as intended. That has to happen. And then, you know, 2 becomes a candidate because it timed out. It's no longer a follower. It requests votes, but look, 1 also became a candidate. Sad times. You know, 1 requests votes, and then things are voting for each other. This fails because there's still no leader. My leadership elections are just slow for some reason, and it's not like I coded them badly or anything. I coded them very cleanly, so I don't know what's going on here. But yeah, I mean, I don't know. You know, both 2 and 1, servers 2 and 1, are both trying to call elections, and you can see here 4 submits. You know, term sync fail means that its term was out of date when it received the vote request, and so it resets its election timeout. I think that's what happens, yeah, because the sender's more up to date than it is. Same thing happens to 0, same thing happens to 3, that's cool. And then 1 and 2 are pulling votes. 2 received votes and got elected. But you know, in the time that this has happened, 0 again became a candidate. So this is what I mean. So you know, 0 is a follower, and then you know, by the time these like 3 request vote messages get sent out, 2 becomes a leader and 0 is just a candidate again. So why is my code so slow? 0 should not be timing out so fast. And when it does that, I mean 3 timed out as well, and there's just absolute chaos here. And I'm just glazing my eyes over trying to find somebody getting elected leader and actually winning, being up to date on term. So 2 was a leader, but it sent out an append entries message that failed because one of the things it sent to had in the meantime triggered a new election. So you can see 1 as well, just losing a vote request here, and it's just total chaos. There's no point really where everything is just a leader. Where there is a leader that manages to hold on to the leadership. I guess here you can kind of see it. 2, 1, 3, 2, 1, 3. So 2. To an extent, it's also a lack of parallelization in the code. I think it's probably running on a single core, and then it's just extremely slow. I think I might have to read MIT's advice about this, but it's just kind of hard to debug something like this when it's not systematically failing. It's just extremely underperformant code. That's basically what's happening here. So yeah, in this case, 0 is a leader. I think it's constantly sending out. It's kind of working, but you can see here as well. 0 sends a message to 4, but by the time that message is received, look for ran a candidacy timeout. 4 replied to 0 and did not get reset, or did it get reset? Maybe it did, and then, for fuck's sake, it's just so messed up and so slow. I was thinking at the end of the previous session that what I might have to do in order to sort this out is to... Sorry, I'm getting a bit distracted by something I'm going to have to deal with when I'm done streaming. Never mind, I don't particularly want to talk about it, just a slight personal drama. Not with my mum this time, I might add. Just somebody on the internet, which is not worth worrying about, and that's why I'm just like some random off the internet. But yeah, I'll deal with that later. I have another maybe hour and 15 or so that I want to be streaming today, to see how much work I can get done. Let's just come a little closer or further if I want to fit my whole head in the stream. Is it all focused? Just do a quick refocus. Trying to get the sweet spot requires a bit of sort of guesswork, I guess. Guessing that you have enough distance on the scroll wheel thing. Let's tilt this downward slightly. Okay, camera, mic. Yeah. Sorry, what I was saying at the end of the previous stream was I might like to actually benchmark it with a clock. So find out just how long everything is taking and why it's just so bad. But that'll require me to actually think about how to do that and how to post times, which I'm really not sure about at the moment. My back is a bit messed up, so I'm gonna have to move all the way over here so that I can lean on something. Maybe I should just return to my usual streaming setup. Actually, let me do that. It's just more comfortable. I just kind of felt like being in this different position for a bit. So let me do that. Yeah, this is my usual position. Oh, sorry about that microphone. Actually, hang on. Sorry. Let me just sort all this stuff out and then I'll resume. by some miracle the camera is still focused. I don't know what even. Yeah, like this is the kind of position I'm happy to just. Yeah, I don't know how I managed to do all that moving and then retain a focused camera. That's quite crazy, isn't it? Camera, microphone. Move the microphone into position as well. So camera and microphone. Mic, camera. Settled. So yeah, I don't know about whether I should be benchmarking stuff. What I could also do is fiddle about with, these numbers, like the election timeout. You can see here, the election timeout is something that honestly I've already increased it from 500 and it's just still hella slow. The heartbeat timeout is pretty small, and so it's making me think this isn't the problem either. Election randomization is something that I should probably increase, because honestly there are so many split elections and things. That it's probably a case of the randomization being just so small. Maybe try setting randomization to 300 and see if that will help. What did I say? If I do Control C and Control V, that works. In Windows, Control C and Control V are your standard shortcuts for copy and paste, but because this is, I don't know, it picks up lots of Linux conventions, then sometimes these keyboard shortcuts don't work. Dear. This is still failing hard here. 5 terms. What is, how many heartbeats does this thing manage to send out? Like, for real? It receives input here. I've increased the election randomization. There are so many vote requests. Let me see if I can parallelize it. This is I've googled a name of a variable just that's in my head, as something that I think might be able to determine how many CPU cores and processors I'm using. So I'm just thinking about how to parallelize the codes. Well, I mean, it says here that, it should be the number of cores. I guess it would be, it would be diligence to check what the maximum process number is set to, just to have an idea of how many cores we're actually using in this algorithm. So I'm gonna just run that in the initialization code, make. It is called make, isn't it? Yeah, here it is. I'm just gonna very quickly just print go mac prop thingy from runtime and see. What the hell is this? I thought it should just give me a number if I did that. Am I supposed to put a 0 into this like function or something? Is it even a function? It should, yeah, it should be. I think there should be a 0 yeah. What's probably happened is I've printed a function that this is actually a function, and I'm supposed to put 0 in, even though I don't know what 0 is for there. Good. Help me out. Function integer integer. What? Why? I have no idea why I'm passing a 0 into this function, but fuck it, it seems that that will do something, so let's just do it. Go test run 2b1 into console. 4, yeah, it's on 4 cores. This is a quad-core CPU. I guess I could set it to 8 technically. I don't think it would help though. If it's not working with 4, it's unlikely to ever work. Look at this. In this code, in this instance, I managed to get 100 in and committed as well. Except, okay, the 0 hasn't validated that it's been committed, and so it's saying, "Oh, failed to reach agreement." If all of these numbers, which are the commit indices, are 1, that means everyone committed, and that's what's then going to say 200 failed to reach agreement, instead of 100. So yeah, I mean, see, I increased the election timeout, that didn't help. I'm really at a loss. How can I speed this up? Why is it so slow? It's. I mean, I appreciate there's a lot of context switching and sending messages, but I haven't explicitly done anything slow, have I? Written anything that's just really, really slow. So just looking at one of the old tests here. This is just, repeatedly trying to input something where there is no leader. 4 and 0 simultaneously throw an election, which is just a nuisance, but it seems to work. That is a lot of random votes. 0 and 4 vote false for each other, that's funny. Are there any true votes? Hardly any. Yeah, when the sender dominates the receiver, then this thing will immediately grant votes, it will react. But this is, okay, well, I mean, again, we have a ton of request vote messages. No append entries until here. 4 managed to get elected as a leader. It managed to even send out a heartbeat and reset pretty much everyone except 1 who got disconnected or something. Oh, okay. 4 is actually a functional leader here. Do you think the problem is that there are too many print statements? That could be slowing the code down. What if? Okay, so here's an idea. Hey, here's a concept that works. 20 million other white wrappers emerge, but no matter how many fish in the sea, it feels so empty without me. Alright, listen up. Kill function. What if instead of using my print debug statement, I just type fmt.println, and I do the same here. So I'm using the always on print function rather than my custom print function, because I can disable my custom print function by setting this to 0. And what then if I just run the test normally here? What happens? Is the code, do you think the code will be mysteriously so much faster now that basically all the printing is disabled, except for the stuff at the end? Possibly that will actually work. Well, I don't know. Bless RNG. Nah, see, it's still very much not working. The outcome is just terrible. What I can do as well is in the output print function, I can just cut down on the amount of sleep. In fact, let me just disable the sleep here. The reason this sleep is here is because I want to lock, which is effectively killing all the servers, and then have a little grace period, so that before the next test starts, effectively. So that, because I had the problem before that the old instance of the program being tested in one test was interfering with the second test, which is supposed to run a completely new instance, but Go is apparently not intelligent enough to do that, or maybe MIT is not intelligent enough to figure out how to take advantage of that. Yeah, lots of different things when your code is just crazy slow. No, see, none of this is fixing the problem. This outcome is all the logs are empty outcome. So this outcome is very much the get wrecked outcome. I do not know how to improve that. I'm going to keep trying it a few times just to see a few outcomes come out to kind of get an average of what's going on. But I think honestly, I might have to literally, yeah, time things, get times up. In this case, okay, so this was the complete failure case. This case we have 4 things have written, but 0 commits. Let's have a few more. Everyone failed to write a single thing. Let's try again. Everyone wrote, nobody committed. Not even the leader committed. Maybe the problem is, I mean, I don't understand why this test is so, it's only giving about 4 seconds of time and it's immediately saying, you failed. So it's just super fast. What happened in this case, same thing, everyone wrote, no one committed. I want to get, I don't know, I want to repeat it a few times to see if I can get the first thing actually did successfully get written and committed case. No, one thing wrote, nothing committed. Everyone wrote except one, nobody committed. Can we get the classic? A few more commits, but even commits are rare because my code is so bad. Even a single commit. Here everyone wrote, no one committed. Maybe, the fact that I've actually decreased the heartbeat timeout, so I'm trying to make that as slow as possible. But it still doesn't seem to really be doing anything. Okay, well, on the upside, the code has improved because it's not like completely crashing. It's not. There aren't any crashes. It's just failing to be fast enough, but it's not crashing. So that's an improvement. Whew, what to do, mate? I am properly stuck now. I could put times in. I could try to analyze a log once I've looked at a time. First thing I'm going to do is see if I can get some advice from ye old MIT. Or indeed, read the test. See if I can get some documentation on the test. This is the thing, tests 2A1 and 2A2 were systematically passing. This is it. This is the test that we're doing, right? There are 5 servers, and in 3 iterations, we're sending data. Index less than or equal to less than this plus 1 4. So it goes from 1 to 3. and it sends data 100, 200, 300. And it's testing, it's testing it quite. You can read the test. It's quite thorough. It's like, you don't commit before start because we have a function that I guess reads commit indices. This, which is, I don't know, where is it pulling index from? Oh, I don't know. Never mind. And then, it expires, but it throws the config.cleanup or whatever it is, throws that error that we keep getting. That the test just check timeout, that's it. Oh, it's not actually that, sorry. It's failed to reach agreement. Right, this is it. So it's in the one function in the test, which I've managed to close somehow. Let me just, declutter this. The variable tab sizes are annoying. It makes it harder to close things. Yeah, loads a copy of test. Yeah, here, cfg.1, and that's failing because if index is not equal to -1, somebody claimed to be leader and to have submitted our command. Wait a while for agreement. And then we have a time now, a bit of a time sleep. If retry is false, why would retry be false though? Well, retry gets set to true in certain situations, doesn't it? Oh, no, I think retry is inputted into 1. And here it's saying retry is false, so it's okay, one shot. Do the commit. It's saying failed to reach agreement. If we get to here, return index, committed. And it sleeps a bit, it waits. And it's saying 4 times since t1 in seconds to be less than 2. So the for loop is just running repeatedly until it times out after 2 seconds. And it says, okay, I want this shit to be committed within 2 seconds. No retries. Yeah, that gives a pretty clear idea of why things are so slow, I guess. Maybe I should log time now in each heartbeat. Yeah, let's do that. My first step in trying to figure out how slowly things are actually happening is gonna be to try in my heartbeat codes in the log to try to actually figure it out. How long did the heartbeat take? So it prints a message pretty much all the way at the end here, and then there's a recursion. So okay, it would be good to print a kind of time. What does time.now actually do in Go? Let me just find that out before I do anything. So a tour of Go. Time. Print learn time dot now. Well, it prints out like a full-on time thing. 11 p.m. Well, this is 2009. Go print seconds. This would Yeah, the Go package. Let's see if we can just find how to print. I know how to do this in JavaScript. I mean, fair enough. But yeah, I would just like a kind of give me the time. Give me the. Is this gonna do it? I mean, this is now still. It's just. Second is a function. What? This gets attached to a time object. My bad. Stupid. Zero. Okay, yeah, this is the kind of idiom that I would imagine. Because it's the second now, and so you get the time now with this function, and then that gives you a time, and then you run its second method, which will give you the number of seconds. Oh, actually, I want milliseconds, don't I? As well. God, do you know what? Maybe it's easier to just print time now. But no, I want the damn milliseconds. I'm wasting time when I could just be, to be honest, doing what the tester is doing and just doing a T1 is time.now, and then you just go time.since and print the results in milliseconds. I think that's a much more sensible thing to do. So basically, yeah, when the leader code, when the heartbeat starts, I'm going to do a start time variable, which is just going to be time now. This is a modern programming language, and so it should have a nice modern package that will allow me to do what I want with time, nice and easily. Start time, time since start time of the heartbeat. Part of me is thinking maybe I should do a print message at the beginning of the heartbeat as well. Sends all these heartbeats out concurrently. What is taking so long? Nah, I think I'm okay just doing it this way. Time.since.startTime, and I want that in milliseconds if possible. Can I get the time in milliseconds? Well, it's allowing nanoseconds. What about milliseconds? What? How is milliseconds not a thing? Am I just going to have to use nanoseconds? Well, I can use nanoseconds. That's fine. Okay. So what we're doing now is we are measuring how long heartbeats take. Let's see what happens. Let's see how long heartbeats take. This is, it's not, the thing is, the heartbeats asynchronously send append entries, as in the heartbeat loop asynchronously sends out these append entries messages, which means that, this number will probably, the length of the heartbeat is probably not going to be, oh shit, debug needs to be on. It's probably going to be short, but, the append entries messages then take ages after the heartbeat has supposedly finished. So this might not be that insightful because of that asynchronicity, unfortunately. But, hope for the best. Yep. All right. Let me see some heartbeats. This is in nanoseconds. Okay. Have I coded it correctly? Because this is some fuck off massive number. What? Yeah, look, I've said, time since start time dot nanoseconds, and start time is scoped, I believe, to this function, this instance of heartbeat. So here I'm looking at heartbeat number 1. This is the first heartbeat in the entire. It's not just the first heartbeat; it's the only heartbeat in the entire test. Um, this is nanos. Okay, that's milliseconds. That's seconds. 481 seconds. What? I have a bug here. Sorry, I think I have. Nano is a million, and so this in seconds is this much. 400 and it, but like this test did not take 481 seconds, so I've done something wrong. Do you think it's 0.4? Oh yeah. Sorry, nano is a billionth, not a millionth. So okay, this is how long it actually took in seconds. But no, if I just wrote, return the number in seconds, it wouldn't return a float, it would return an integer, which is no good. It's telling me it doesn't have milli or microseconds. Go time milliseconds, please. Surely this has to be a thing. You can divide by this integer. This is an untyped. No, it should be typed. This doesn't make sense. Fuck it, I don't care. I'm going to use nanoseconds. I really don't care sufficiently to fix that. This one heartbeat took about half a second. And then there's a timeout of just really, like a really small amount at the end. Heartbeat taking half a second is, I think, categorically too long. So I think part of the problem is that maybe we should not have 2 leader checks. Among other things, to be honest, that we should and should not have. But like this leader check is redundant. It just fits into send heartbeats. Oh dear me, I do not know. Time sleep, heartbeat, timeout, which is currently set to like 0.1 seconds. I think heartbeat timeout is kind of unnecessary the way I'm doing it now. And then, it does this stuff. For every pair it adjusts indices. That's part of the heartbeat as well. So do I make that concurrent? Or do I leave it there? Does this come with a timeout? No, this is governed by the heartbeat timeout, which is like 0.1 seconds or something. There's no other timeout. Surely 0.4 seconds is fast enough. 0.4 seconds is pretty fast. No? Maybe the problem is that the heartbeat timeout is not giving this a chance to come through. So, yeah, I'm going to have to, I think, do another print statement for heartbeats. But this print statement is going to be a bit different. It's just going to be heartbeat begins here. H start. How do I put? Let's just put 0 for start and 1 for end. No, let's not do that. Let's do because we already have so many numbers. I don't want to put more numbers in. H. So heartbeat complete. What's a good way of denoting heartbeat complete? With a line? A hyphen, sorry? That's like heartbeat settled, and heartbeat start is going to be that. And beats number I should definitely have, but I should also just, I don't need any of that stuff. What's the problem here? Beat number is undefined. Looks pretty defined to me. Yeah, sometimes the static analyzer needs some time to adapt. It doesn't automatically adapt always. Alright, let's see if we can get more than one heartbeat in this stupid output. You know, the lack of heartbeats must be part of what's causing the slowness. Okay, we have 10... No, this is 5 heartbeats now. So the first heartbeat starts here. You know, server 4 in its 4th term starts its first heartbeat. During the heartbeat, you know, there is a timeout. It's managed to send the message to 3, 0, 1, 2. This is an old request vote message. You know, all of these got subdued. And then it said, okay, cool. It's done. It's, you know, because the append entries message gets processed per heartbeat. And so, you know, if it times things out too fast, then the append entries is not going to actually get answered with acknowledgement of receipt. And maybe I should tag append entries with the number of the heartbeat just for debugging purposes. I'm not sure, but like, you know, you can see it here. This message got settled. This message got settled. This one and this one, and so all of those got settled. Probably before the heartbeat. I don't know. Next index is still 1, but that's probably because no data was inputted into the algorithm successfully before then. Yeah, because this is the first time a leader was even elected. So again, we have so many split elections happening in the first place that it's causing instability and chaos. But yeah, you know, this happens, and then it tail recurses synchronously. Whoops, I'm looking at the wrong thing. It does do it synchronously. There's no way tail recur. This should be asynchronous because it has a timeout within itself. You know, it does that, and then it does the same shit. It sends messages to 3. And then look, 2 timed out. I mean, how is 2 timing out so fast? 2, you know, 2 had its election timeout reset here. The heartbeat took 0.2 seconds. Yeah, do you know what? It is just confusing. I am just going to divide the fucking number by a billion. 1E9, did we say, is what a billion is. Let me just check that this works in a tour of Go. So, what do you mean undefined? Time.now is, you know, type time.time has no field or method nanoseconds. It does because I just used it here. Fuck it. What I'm trying to do is divide by a billion. You know, Go can often make, because of its strict typing system, it can often make it difficult to do that, which is kind of annoying, not gonna lie. It just says times 0. This is what I mean. It's doing integer division. I wonder if I can just run float64 to convert this into a float first. Is there a heartbeat in here? Yeah, it's working now. I'm dividing by 1e9, which I'm pretty sure is the nanosecond division. 1e9 is what the wait? What is 1e9? This engineering convention is confusing me. Yeah, so you know, nano is a million, micro is 1,000 milli is 1 second. So yeah, this is. Look at this. This heartbeat actually did genuinely take 2 seconds. Well, we had one here that's 0.3, but then 0.2, and then what? 2-second heartbeat. That's crazy. In the end, again, it's just not working very well. Passing this test is going to be a mission, to be honest. So yeah, I just randomly had teardrop pop into my head. Has a vocal sort of ornament on it that's just really spectacular. Elizabeth Fraser of the Cocteau Twins sings in that song, guest appearance on a Massive Attack song. It's quite a popular song. I mean, pretty good, maybe a bit shallow, but it's no biggie. That kind of thing. Okay, focus. Oh my god, I'm getting hazy eyes now. What can I say? So yeah, okay, fine. My timing method works now. Again, just looking at my log, you know, this is a full 0.2 second heartbeat here, but it's like, why is this happening so fast? The candidacy timeout. I mean, look at this. 2 became a follower pretty early on, right? 2 follower resets. That happened. Maybe I should be debugging using actual time, exact time. Do you think that would slow down the debugging substantially if I just printed exact time in the console? Or just use like some sort of logging plugin that prints with times? I don't know if there's such a thing. Because I feel like I really need to know. Like, I know in which order things happened in principle according to the log, which is it has its own log to pay attention to, as in the console. Sorry, standard output. But like, look at this. I mean, 2 definitely gets reset as a result of this append entries. This triggers an election timeout. But then how is it becoming a candidate so fast? You know, this barely has a chance to like. Look at this. 3 becomes a candidate after this append entries is sent out. So election resets are just slow as fuck. I think. Is that it? My append entries messages definitely need to be printing success. That's something I'm just going to fix up now. Just so I know, is React true and is success true? I wonder if Go has a nice like JavaScript type form a sentence by using, I can't remember what the name is, but that you can write kind of inline text with annotations for variables using dollar curly brace notation. I don't know what it's called, but success is reply.success. So I can log all of this stuff here in the reply section to this particular RPC. And I'm going to do that in request vote as well. Request vote strictly already has the vote granted thing, which is the same as success, I guess. But I'm also going to put in react. It should just be identical notation because I've programmed it the same way. Alright, now let's just make a new... Let's just make a new kind of... do another test and make a new log to just gawk over for like ages and ages. I have to keep here because I'm just jumping around so many files now. It's just complete chaos. Okay, so our new log. Whoops. Yeah, because doing this command should save. I want the latest copy of this, damn it. Okay, yeah, still very much failing to do even the first one. I'm also, oh yeah, there's no output here because, well, nothing has really committed. Oh, the things that have committed, strictly, they could be sending output. Because things after, as soon as they commit, see that, 2 output 1, so 2 managed to actually output a number. But I think this particular test 1 for part B, 2B1, this test is not testing output because it seems to just not react to output happening. Actually, believe it or not, there's 0 outputs, the first 1, 2, and 4. So this actually came pretty close to getting consensus, but that means that the tester is explicitly looking for everyone to have committed in order for it to say, yes, it succeeded. And that's so rare, there's such a low probability of that. So, as they would say in the speedrunning world, we need to find a more consistent setup for this. Okay, let's have a look at the heartbeats again. So the heartbeat times are logged with H minus. 10 heartbeats, wow. This was actually one of the better tests. 0.4 seconds, 0.2 seconds, 16 even. 0.16 is pretty fast. Another 0.16, 0.35, 0.14, 0.18, 0.16, 0.12. This is actually working pretty well. 0.3, 0.2. So, I mean, but look at this. This is, yeah, so this thing seems to have managed to preserve its leadership. So, vote request, which is actually called request vote. Sorry. Request votes get sent out, for a bit here, and then something finally gets elected leader. Where's the first leader? Candidate, follow. Come on, scroll, keep going. So the first successful leader election happens. I've missed it. I've skipped over it. 4. You see, append entries is happening quite a bit. The first successful leader election happens here. And so then we have a few extra request votes happening. You can see there are not too many request vote sends, which is good. There shouldn't really be any more request vote sends. So these are just replies to old request votes. Because, send is the right pointing angle bracket, response is left pointing, and minus is acknowledgement of response. So every RPC, which is a message from between servers A and B, whatever A and B are, every RPC logs 3 sentences. But this is going pretty well. You can see here, the last request vote is this one. So the one on line 200, if I can just dig it up. I clicked on it and it didn't update the damn thing here. Maybe I should have gone backwards, that would have been faster. Whoa! Oh yes, obviously. Yeah, so this is the last request vote, and then the server actually held tight, you know, and worked. So everyone is saying react true to the append entries messages. There's not a single react false, which means this is really working quite well in terms of the voting cycle. But nonetheless, it seems too slow. This is the thing. So it takes it takes until line 200 for something to get elected. If we look at the inputs, the last input happens before line 200, and so this really is forcing me to elect a leader so fast. It's crazy. Do I nominate something to be leader when the algorithm starts? Like, do I say if I am 0, then I should start out as leader? But because I don't think that's what's supposed to happen. That would fail some test, definitely. It would say like, oh, there should be 0 leaders in the beginning. Because that's how the algorithm's supposed to work, pretty sure. Pretty sure, mate. Pretty sure. This has gone a bit chilly. I took my jumper off, which was a mistake. Camera position's pretty good, actually. Unfortunately, my work ethic's not too bad, but I'm just failing really to figure out how to, deal with this. It's really, really messy. All these request vote messages. When was the last request vote sent? So yeah, I mean, sure, there are all these append entries, but when was the last request vote sent? Here. And the leader was elected here. Started sending heartbeats. The heartbeats were fast and uninterrupted. It was actually working well. There wasn't a single timeout. But like, it managed to send in one piece of data. And then what, timed out immediately, as in this almost managed to establish consensus on that piece of data. Why did it not, though? Surely, at this point, where the input has successfully ticked, the leader, which is 4, should have the thing in its log. Next index is 1, so it should be sending in every append entries message some data. But it seems to not. What if the heartbeat timeout is too slow? What if I should really be increasing the length of the heartbeat just to give these RPCs a chance to actually come through? Because at the moment, I think this could be what the biggest problem is. So the fact that this, which reads the replies of, it reads the replies. So we're reading the replies of all of the peers to these messages. Maybe this is just happening too fast. Maybe the messages are not really being given a chance to come through. So, the messages get acknowledged. Replies come through. Successes come through in the replies. And then the send entries. But yeah, basically, I mean, replies get set to success gets set to true. That's what's triggering progress, basically. Don't forget the way that success works in the write phase. If a follower replies success is true, then the leader progresses it and sends it newer data. But Okay, so that happens here, or, it happens before the reply to append entries, and so let's have a look at some heartbeats and see if we can spot success trues coming through before the heartbeat just gets ended. But the problem is we don't have a statement that says when do these things get polled, all the successes. As in, when do we check for successes? When does the leader actually take stock of all the successes? So I need that to be printed as well, I think. So I'm going to do another print. I'm going to call it h left arrow because why not? It's kind of arbitrary, I don't care. It's kind of like, oh, all the replies have come through, let me figure out what's going on, and therefore I'm using this, which kind of means reply, the left pointing angle bracket. These are just conventions that I'm just randomly coming up with. Yeah, and then it would be nice if I could log how many successes there are. Can I just print the entire replies? Oh no, I'd have to do a map. Unfortunately, I can't do that. Okay, never mind. That's fine. I could always do a new data structure that just logs successes, but I feel like that might be overkill. Let's instead do a just print this statement for now, and let's see where that statement is dropping. If this statement of okay, now I'm about to start registering successes, if that drops before the replies to the append entries have come through, then we know we have a problem in the sense of it being too fast. So, okay, here's an example. It takes stock immediately here. Is this one of the cases where input has even been received? Yes. Actually, interestingly enough, basically all the servers have even committed an entry, except for... No, all the servers committed an entry. But then why is it saying failed to reach agreement on 100? Probably because it wasn't possible to input another entry. So, the inputs all fail here, the inputs all fail here. Input comes through. Here is the first successful input, and that's, the algorithm just stops there. So the fact that there are no inputs could be what's causing the problem. It's trying to... The tester is just sending data in so fast. There's no buffering of data or anything. It's just unable to process the data fast enough, kind of. Again, just looking at the one that succeeds, that happens here. In this case, okay, the heartbeat's already started. It received an input asynchronously, but that's probably not going to go out in the heartbeat. But then, you look at the next heartbeat. The third heartbeat, and you immediately see, new data has been sent through. Not all of them have managed to receive it though. So look, this is 0, 1, and 3 have received data from 4. This is not getting updated, but 2 failed to receive data. And the reason for that is, 4 sends a message to 3. Here is the receipt. 0 has received from 3. Sorry, 4 has received from 3. 0. This has 2 leaders for some reason. Why on earth is 0 sending out messages? Is that a bug? Yeah, 0 is sending messages out. Oh, 0 was leader, but then it got 4 timed it out. Oh, for fuck's sake! So there was another timeout here. How fast were 0's heartbeats? A bit slow, for some reason. Heartbeats being slow is something I don't understand. Well, I mean, we can't lock the entire heartbeat system because that would completely block the whole program. And if a leader is, you know, completely locked to run the heartbeat code, then unless we have parallelization, we have no way of executing any of the other code, because that just uses up the threads, the execution thread, like fully permanently. Distributed systems is hard, guys. Yeah. Close the window. I'm gonna get like ill or something. Dear. Eho. That was Latin. You know, I don't know, like. Fine, so 0 sent out some messages, who cares? Let's have a look at 4. This heartbeat, nothing will have happened, because it wouldn't have picked up the information, probably. This heartbeat from 4, it sends a message to 3. This is just an old request vote message. But yeah, you know, there was an append entries that went out to 3, that got appended. 0, likewise, that worked. 0 must have term sync failed at some point, because it's on term 1 here. But then when it gets settled, it's on term 2. So yeah, 0 must have become a follower from term sync fail. Why does it not print a message that it turned into a follower? Because it probably took a while. It probably took its sweet fucking time to turn into a follower. It's all happening so fast. I almost don't understand how the tester is so stingy on its speed requirement. It just seems, I guess it's a very strict test, but I mean, surely this algorithm just cannot work that fast. I don't know. I think a flea just flew into my fan. Well, I barely noticed that, but still. Death happened. Great. You know, 4 managed to send to 0. It was replied with true. 1 replied with true as well. So 0, 1, and 4 all have the correct. No, 0, 1, and 3 all have the correct index. But 2, for example, it got cut off, because I guess the election timeout was so fast. The message from 4 to 2 just doesn't seem to have. It was sent here, but there wasn't enough time for it to come through fast enough. You know, it sends all these messages, but like the leader just cannot send messages fast enough. But there's nothing strictly slow about this code. It's just, okay, fine, it's asynchronous. But it should be asynchronous because the send is going to block. Maybe the send needs to happen synchronously and call an asynchronous handler to the send. So maybe we need to just make sure that all these sends are happening not in separate Go routines, but straight up immediately. So see how it says append entries, sender. This is usually getting run in a separate Go routine, which strictly you would think is necessary because look, this is where it blocks. This is where the send, you know, the code waits, and I think sending append entries has to be done in a separate Go routine, in a separate thread. Can you even imagine? Like I don't send it in the thread. Well, I mean I send it all in the current thread, but then don't react to the messages. Instead, I just terminate this. But that's not how I can't do that. The call function doesn't allow me. The call function will always wait until a response is received. Even if I say, oh, I want to just cut it off, do the send and cut it off. You can't do that. You know, the thing that makes the call function does a send and then waits and blocks your thread. So this has to be, the call therefore has to be done asynchronously. This is crazy. I mean, There's a guy I met like almost a year ago. He had a really cute. I can't really imitate it that well, but it was good. It was a good, a nice, wholesome. Wow, I truly have no idea what I'm doing. I'm running out of ideas fast. The one thing I could do is delay this happening by increasing the heartbeat timeout. Is there even, like, let me get some guidance on whether or not there should even be a heartbeat timeout. So I'm going to read the blueprint. Bottom right of my Twitch page has a link to this. It's from the academic paper on Raft. I want to find out if heartbeat timeout is a thing, if it should actually, how it should be implemented. It says here repeat during idle periods to prevent election timeouts. Well, how do you make something happen? It's not possible to prioritize or deprioritize Go routines. It's not possible, I don't think, to schedule a Go routine to run if idle, if there's nothing else that should be run. It would be great if you could do that, because then I would do a run immediately call. Maybe I need to implement my own priority queue for tasks, but that feels like it's going too far. That feels like I am circumventing the basic Go task scheduler. You know, like I feel like I do need things to be prioritized or deprioritized. When it says repeat during idle periods to prevent election timeout, I might have to investigate, read the paper and find out if, because it has some references in it. That's nice. And then just see if it has something to say about idle periods and election timeouts and that. Heartbeat timeout, is it even a thing? That there is a heartbeat timeout? Because heartbeats, it's not like they happen that fast. But then again, the speed at which they happen is... If things are working properly, heartbeats tend to be quite fast. So you can see that here, where I say heartbeat settled. Heartbeats get settled 8 times. 0.26. Let me just... Sorry if this makes things a bit less visible, but I just want to see the times. This one took 0.8. So it's fair enough that there was an election timeout if a heartbeat managed to take 0.8 seconds. That's a bit long in this circumstance, this particular test, 5 pairs and whatnot. Heartbeat, okay, fine. It took its time. That happens sometimes. Maybe I need to kick stuff out of the heartbeats. Some of the, like the whole commit thing, maybe that needs to leave the heartbeat and go somewhere else. You're probably right. That should probably not be in the heartbeat. Maybe that will fix everything. I'm going to try that. So I've just had the idea that, when I was saying, like, oh, there are things that the leader needs to keep doing. There are things the followers need to keep doing. Well, actually, no, it was just the leader that needed to keep doing. But yeah, basically, when it comes to the commit phase, how fast things are being committed, there was the question of whether or not commits should be done on every heartbeat, or if they should just be run in the background. I already have something that is running in the background, namely the apply phase, which is checking the commit indices and then sending out messages if they are incremented. So I'm thinking, I may as well just merge that with the commit phase and have that run on a separate Go routine outside of the heartbeat. And then it's up to the Go scheduler to figure out when that should run, rather than it being synced to run after, sort of after every heartbeat, basically. It's the kind of end phase of every heartbeat. Because then there's a bit less locking happening, and the heartbeats would get a bit faster as a result. We wouldn't get the 0.8 heartbeats probably. 0.4, 0.3, look at the times. 0.43, 0.25. Most of the heartbeats are pretty fast. But sometimes we get like a 0.8, 4, and then I don't know if that should be moved. Maybe, yeah, that's the one thing that could maybe help, is if I just move the heartbeat time, move the heartbeats somewhere else. And also, like, if it is in any way possible for me to just like I don't know, man. I would say the way that I've programmed the heartbeats in general, just the whole heartbeat cycle, it's a bit long and clunky, and I feel like potentially what I need to do is oh god, sorry, nudged the microphone. What I potentially need to do is basically make the heartbeat lightweight instead of the shit that it is now. Make it as light as I can. Move, most of the kind of unrelated stuff, the stuff that's unrelated to every append entries entry, move that into some other bit of code so that it doesn't weigh the heartbeat down. Like, I already have a asynchronous cycle that everything is doing, but like that thing is being run by absolutely every, whether or not a thing is a leader or a follower, it is always running the the apply phase. It's always sending its data out to the final kind of output channel. There's a channel that you're supposed to send outputs to, and yeah, that's happening whether or not things are leaders and followers. And I guess that's why I put the commit phase in with the leader heartbeat, the leader committing. I put that in with the leader heartbeat because, I don't know, it seemed more appropriate there. Okay, let's get back to basics. I'm having ideas for what I could change, but no real idea of what I should change. To be honest, like, surely the problem here is that, these inputs to my Raft implementation, those are just continually happening. There are always tons of them before the algorithm even loads. And, they just end so fast. Some data gets inputted sometimes by accident, but for the most part, it's supposed to send in 3 different bits of data, and it at most manages to send in 1. And then if the algorithm's working okay, it manages to commit that 1. In this case, it didn't get committed in server 0. So maybe I need to increase the heartbeat timeout because commits are not being read. Or actually, no, in this case, everything got committed everywhere, but it just, it managed to successfully process this one piece of data. It even managed to, I think, output it to all the different locations. You can see that here, like output 1, output, 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 right? Yeah, so, I just had another thought that is actually a thought that I had 5 minutes ago, but I didn't fully register it in my head, and so it had to come back to me. And I didn't say it probably. But that outputs only ever happen when commit indices are incremented, and so I don't see why we don't just do outputs synchronously at every position where a commit index is incremented. Because commit indices increase monotonically, they never get decreased. And so every time a commit index increases, why not just do an output instead of running a separate routine to do outputs? Shall I just make that change? Because it kind of seems like an obvious change, I'm not going to lie. Let's just do that. Because then we have one less routine cluttering the runtime. You know, this thing that's permanently working in the background, the apply entries thing. I'm just going to completely, fully restructure this. So I'm going to put a note in chat saying moving apply outputs to always happen immediately after any increase in commit index. Hope it works. That was an extensive text post, but you know, let's do it. Very quick change actually in order to do that. First, comment out this entire routine. It's not necessary. And instead, this. That was a cat that's outdoors. It says here if commit index is greater than last applied, then do the apply. But is there any reason not to just do that? It doesn't need to necessarily even be immediate or synchronous, but we always know when this is going to get called, so there's no point continually checking. This is probably just slowing the algorithm down, because we're doing lock and unlock all the time during idle periods, and we have no way of deprioritizing. So maybe this is what was causing the problem the whole time. Let's... I don't know. Maybe that's it. Okay, so any position where commit index is edited, I need to control F and deal with that, basically. So here, commit phase, that is where commit index gets edited. You see here, it says I is a number that is strictly greater than commit index. And here it is saying commit index is set to I. That means that commit index is increased. And so here, let's run and apply immediately after the commit index. What I'm going to do, just to make sure I retain the separation of concerns between commit and apply in case I really need that to actually be a thing. I am not going to do it exactly the way I initially thought, by pasting in the just do and apply every time there's a commit, but I am going to do that, but not synctatically. Instead, I am going to make a function, a new function that's called apply, same thing, apply entries. But what it does is crucially, there is no lock and unlock. Crucially, it does not tail recurse. Instead, it is run precisely when it is needed to be run by being called immediately after commit index is increased. We also do not need this test. Instead, it literally just does this. Every time commit index is incremented, we do this. We have a slight problem here, which is that commit index is allowed to be incremented repeatedly. It's allowed to be incremented in many jumps at once, basically, even though that's not really going to be happening very often. And so what we're going to do here is run an infinite loop, just to drain. Every time this gets run, it's going to drain synchronously into the apply channel all the messages that are committed but haven't yet been applied. Apply is output, it's the same thing, so that's when things are getting sent out of the algorithm, whereas commit is the step that basically says we are ready to send this, and commit indices get synchronized as well between servers. Whereas apply is more kind of just maintained by the server for its own sake. So yeah, we're going to do a for loop. it should really be a while loop, but we can do while loops quite easily. We just type for no variable, semicolon, do you know, we don't want to read commit index or apply index. Instead, we want to send in the target commit index. Okay. But in order to do applies, we have to lock in order to read the log. Okay, so I'm not going to do what I said I was going to do. Changed my mind. Sosbra. Instead, I'm going to apply individual entries, and I'm going to pass those entries into the function. So the entry is basically the log. What we want is a copy of the log entry, and so I'm going to explode it. Rather than referencing the struct that contains that, I'm going to make sure that it all gets copied out by typing rf.log data and index. Is that all the stuff that we care about? So we send command valid. Yeah, so all this stuff is just going to be inputted. So data, which has type command, is command a type? What the hell is the type of the data? Right click, hover over this, hopefully it will give me a type. Oh, it's interface type, okay. Interface is the arbitrary, this can be anything type. Index has type int. And what we're going to do is, fuck. You have to be careful. The idea I had would have implied that things would get applied out of order, which you're not allowed to do. Are you? Wait, no, but we're sending indices through. So it doesn't matter what order that they get sent in. If the index has been validated, then we can just asynchronously send them. It's just that we shouldn't asynchronously send them, because if things like it seems really dodgy to say like, oh, I'm going to send the thing that's at index 4 before the thing that's at index 3. Like, no, that seems wrong. Okay, so just be careful. Okay, so what I'm going to do instead is, because last applied is getting incremented one step at a time. That means that we need to make sure we're sending out things one step at a time as well. So, oh my god, surely the fact that you're incrementing last applied means you need to lock the damn thing as well. I'm getting so confused. There are so many different sort of questions here. I think personally maybe apply entries should only be triggered. Do you know what we could do? Let's try to make, because I keep getting confused about what the best way of doing this is, let's try to make a change that is as undestructive as possible. So I'm going to try to basically retain this, but try to do away with what I consider the problem, why this could be slowing down the entire program. And that is having the tail recursion, the lock, and the unlock. So let's try to directly edit that out and instead replace it with apply entries is literally just this. We don't need to lock the apply channel because it's never getting edited. This is always just there, and so we can just keep accessing it without the lock. But instead, this now has parameters, which are everything that needs to be here. So last applied, this is going to do an apply. It should do the apply synchronously because I want last applied to be incremented after the apply has happened. So do a synchronous apply. I guess we don't actually need to technically have that happen. We could have last applied independently edited from the actual apply, but I feel like that's also just bad practice. Because then what is last applied saying? We're just two things, one thing that's supposed to do this thing A is supposed to do thing B, and then it's also supposed to edit variable C, which is means that thing B has happened. But the way that I was thinking of structuring it is like thing A edits thing B and thing C at the same time, and then thing B and thing C have no relation to each other. And so if thing B fails, thing C is just claiming that it succeeded, if you see what I mean. So that's also a bit of a no-no. So maybe I have to run this synchronously, but like basically what I'm saying is I want to just be running this, but without the lock and infinite loop. So why not infinite loop, but yes lock? So okay, I was saying about making the most undestructive possible change. Let's keep the lock, but ditch the infinite loop. So now I have a slightly different paradigm. It's concurrent. Concurrency has so many different design choices. This is why I like it. But it is what makes it hard. And unfortunately, really made very little progress today, as a result of it just being so difficult. But yeah, basically, what I'm saying is, let's do the lock, but don't tail recur, and that means that this only ever happens once. And this should be replaced with an infinite loop. It's like a while loop. While this is true, do this. Increment last applied, which should realistically be happening after the damn apply happens, just because logically this is registering that the apply happened. And this should also be down here. Damn it. Yeah, so this is a... oh my god, what the hell? So I put semicolons in. The semicolons have to be there, surely. No, apparently they don't. So this is supposed to be a while loop, basically. While this is true. I guess the reason it's interpreted as a while loop by the Go runtime is because, or even the Go compiler actually, sorry, is because this is a logical expression, whereas for loops usually start with an assignment operator. And so the first logical expression is the exit condition by convention. And then you also have a statement for what to do after each loop, and that follows this. I don't know. But if it's just deleting my semicolons, then that means it should work. Like if I do 2 semicolons, it'll not delete them, it'll just mess up. But I put this in the right place, and I put a because it is supposed to be the second semicolon, and I put a semicolon here and a semicolon here, and it automatically deleted them, which means I think I'm good. For syntax, for my while loop. So basically what this is doing is it's draining the things that need to be applied, it's just applying them. It's all within the log, but there's no tail recursion, and that means that apply entries has to be called, whether or not it's synchronous or asynchronous. I think we'll leave it asynchronous, but it gets called every time the commit index is edited, right? So this statement, I'm going to call it, it's like in my Pokemon Go bot. I have an asynchronous sending should be happening every time there is something to send. And so every time there is something to send, I run an asynchronous sender function, which keeps sending until it has drained everything that needs to be sent and then leaves. That requires a lock. In my Pokemon Go bot, there was a lock. There was a this.sending variable on the thing that was sending, this being, just referring to my own object variables. And sending was set to true. The code was actually looped itself, but it was tail recursive, but send was always set to true. If and only if there were things to be sent in the send queue. And then when basically the function always returned immediately if sending was already true, because that meant that another copy of the function was running. We can achieve exactly the same thing here by having a lock. So, my Pokemon Go bot didn't have an explicit lock, but on the other hand, here there is a lock. And it's, very much this function locks and then unlocks when it's done. And so it's not possible for another copy of this function to be running at the same time because of where the locks are placed, and so we're safe from that. God, I love this. It's so complicated. Basically, okay, so just checking that I'm still live. Oh, it's been 2 hours. I should probably leave it now because I wanted to go for oh shit, I need to go for a walk. Okay. Well, I'm gonna do some last ditch attempts to get this shit working, and then I'm gonna go for my walk. So the change that I'm just pushing through now is that every time commit index is edited, I run apply entries, which is saying entries should be being applied. So in the leader code, this is the only place where commit index is edited. Followers edit commit index when they are receiving RPCs. Append entries RPCs here. Commit index is set to something. So this is also a queue to run apply entries. Well, things have been restructured. I'm running asynchronous apply entries because I think apply entries is pretty low priority. But now it is not locking and unlocking and running all the live long day. So hopefully, you never know, but maybe this has fixed it. Let's find out. Or maybe it was just fully. Oof, that was fast. Why was it so fast? It probably crashed. Oh no, it crashed pretty fast because it managed to commit something that is not to be committed. Apply error. Committed command nil is not a. Okay. Yeah, you just got to be careful with the indices, I think. So I'm running apply entries. That's fine. But here, while commit index is bigger than last applied, do the applies. Oh, wait. Oh, shit. Sorry, I haven't specified which index I'm actually applying at. My bad. You should be using last applied to determine what is being applied. That's fine, I am doing that. But I'm also somehow applying the 0 entry in the log. Last applied has to be initialized to it has to be initialized to 1. I'm an idiot, sorry. Fuck's sake. Last applied actually does have to go before the apply, even though it's logging what was last applied, because the thing at last applied is the thing that is then applied. So the only way around this is to say to put a +1 here, which is probably more idiomatically correct, but I don't know. Never mind, this is fine. It'll slap you on the behind. Let's go. Alright, I was not immediately going to finish the test now, thankfully. That was a stupid mistake. Failed to reach agreement. Same old, you can see here. I mean, is output actually happening? Yes. What the hell? Only one output managed to happen. 3 output 1. Did that must have happened quite close to the end of. Oh shit! No. 3 output 1. Yeah, but 3 is the leader. So that means that the followers are not successfully outputting. Even though, didn't I edit the follower code? I said, commit index gets set to this thing, and then I apply entries. Surely that's fine. Okay, I'm going to do a slightly sketchy thing here and run this synchronously. Oh no, you can't run that synchronously because it's within lock. Oh shit, I'm not even allowed to run this synchronously because it locks and unlocks. So instead I'm just going to run the test again and hope for the best. Plus. There's only, yeah, outputting is not working correctly for followers for some reason. It's just not working. On the other hand, neither is committing, so the code is still completely busted. Oh, that's why it's not working for followers. My bad. Yeah, obviously, if there hasn't been a commit, but I haven't actually edited the logic of how commits are done. So in order to test that the thing that I just changed works, I need to come up with a What? Look at this. So many failed inputs. Obviously, all of the inputs are going to fail here because there's no leader. The tester is just inputting too aggressively, and well, okay. Now that I've removed that, the code does seem to have become slightly better because now writing seems to be happening more efficiently. You notice, right, that the code is not blocking as much because the writes are now consistently coming through. So I've removed something that was basically spawning, well, doing unnecessary checks and wasting time as a result, and so the code is now doing commits more quickly. It seems to be working better, to be honest, now that I've removed that thing that was dragging it down, to be honest. But like, I can still see, I can still see bare inputs being sent here. Okay, a quick change I guess I could make to the follower before I just leave is that, when the code starts, it enters being a follower. But maybe what I should do is when something becomes a follower for the very first time, I should not have a timeout. No, I have to have a timeout though. But no, timeouts is set to, you can see, election timeouts. So what I'm saying is maybe initiating a... This is an interesting little hack that I just thought of. So election timeout. Election timeout is saying, this is how long it has to wait before it calls an election in general. But when I'm starting Raft, why don't I set election timeout to 0? And then the first thing that loads sets it back to the actual original value. We smart. Actually, I've not done that right, have I? Or is it? I can't actually remember the fucking... I need to watch. That's a roll safe meme. He's a comedy rapper, I think, who was on fire in the booth. I need to watch that. I've watched the Big Shaq one, but that one references the roll safe one, but I haven't watched the roll safe one, and that is the same guy who is in that particular meme of the black guy captioned with like something ridiculous like I don't know, I don't know if I can make a relevant one to my project, but like can't output the data if there's no data that was inputted or something along those lines. And then the meme is like, can't output the data if no data was even inputted. And then there's this black guy going. That meme, that's who I'm talking about. So I need to watch that Fire in the Booth, BBC One Extra comedy. It's actually usually a show for people to just spit and do live performances of hip hop or grime, mostly grime, I think, but they did a few comedy ones, and this is one of them. All right, so let's take a look at Raft initialization code and see if I can pull this hack on it. Start. make, no, not start, sorry, make, right? Make is where the servers are actually started. All of them, the problem is all of these servers are started completely independently of each other, and so setting election randomization is not, setting the election timeout to 0. Yeah, no, this still makes sense because randomization is intended to make sure that they don't trigger elections at the same time. Excuse me. But timeout is just intended to give leaders a chance. But because there's no leader upon initialization, timeout should be set to 0 initially, and then set back to its original value. So this is the election timeout. What's a good way of doing that? I guess the simplest possible way that I can think of doing that is instead of editing this variable, what we can do is just do a first run type thing where we go like, no, but we're going to have to edit the variable. I don't see a way around that. Sorry. So this is the election timeout. I'm just gonna hack it. I know this is gonna look a bit inelegant. I'm sorry about that, but it's gonna, yeah. var, election timeout is the actual election timeout, and this is the steady election timeout. So the election timeout starts at the transient value of 0 milliseconds, and then it gets set to the steady value after first run. And so all we need to do is put in a line of code that says election timeout equals steady election timeout. These are all constants, actually, except election timeout, which gets edited after first run. But I don't feel the compulsion to label them as such. So let's do that. Election timeout is going to get set to steady election timeout, and the position where that's going to happen is basically, it's not when the leader happens, it's like when one of the vote request messages comes through, or something like that. But I don't want to overcomplicate the code, so instead I'm going to put it at the end of a wait election, because a wait election on first run, it enters here. And then, we have this select thing that chooses what's going to happen. If there's an election reset, then you run this. If after timeout happens, then we do this. But basically, this code will always end here. It will always exit, and so as an exit condition, we can just do this, and that should do it. Hopefully, this will resolve the problem of the first election timeout being so slow that all these inputs happen and get dropped, and then the tester gets angry or whatever the fuck is happening. So having a 0 election timeout initially should prevent that from happening. So I'm going to test it out and see if it works. Ooh, just out of reach, I have some chocolate mini bites I would like to eat. You can see it is a bit faster. There's a few fewer of these stupid messages. And then this thing became a candidate, and every follower, no matter whether it gets its election timeout resets or not, if it's running the follower code, it should get pushed back. I don't know, I'm just going to leave it as it is. I mean, this algorithm is not perfect. I mean, it's not even good, but fuck it. It seems to be kind of, look at this, something got elected pretty fast. So we are making improvements. There's not a single request vote that has happened here. Not a single one. Something is stably the follower, right? On the other hand, all the request votes kind of happened here. One thing called an election. Nothing interrupted this election. Nothing else called the election. That's actually just good RNG. The fact that we didn't have a split vote, but I'm not too bothered. It immediately, it received the command pretty fast. Then it did its consensus shit, which is like, okay, 3, 1, 1. So see, it actually managed to send the entry through quite fast. I wonder if there was another input. Did this? I don't know. I mean, this code seems to be working reasonably well. It seems to have successfully... Oh, the commits are all failing. For some reason. The follower commits have all failed. For some reason. So even though, next indices and match indices are set to the right values, the follower has just not been committing. The followers have not been committing. So is this... Just a quick test, sorry, I'm just going to check. Is this replicable? Sorry, what do I mean? Verifiable, as in, yeah, replicable in the scientific sense. Is this what always happens? That we get this situation where only the leader has committed, and it's managed to successfully send in one piece of data. Yeah, so the follower is not committing at all. So what did I do in order to mess up the follower committing? Maybe I have an error in my code here. Well, no, I mean, the leader commit index is coming through loud and clear. The leader commit index is 1 at the end. But that's apparently not causing, the followers not increasing its commit index, even though the length of its log minus 1 is also equal to 1 at the end. Because it's 2 minus 1. So this is 1, and leader commit is also 1. So why is rf.commit index not getting set? Maybe I need to do a print statement saying follower has committed. Or maybe I just need to stop for the day. I think that's what I'm going to do. Yeah. Because I did want to go out and sort out all of my shit do a quick round, jump around and do, I don't know, just some stuff with Pokemon Go that I want to do just before midnight and then immediately just after midnight. So I'm going to do that now. I have just about enough time to do that. And so I'll leave quite quickly. Unfortunately, not made much progress. Well, I say that, but I'll recap all this next session, but there have been improvements. I'm now reliably getting writes to happen. It's just some bugs with committing and outputs, and indeed inputs, which is also really not happening very much. I think it's synchronously inputting, and so there is no new input, because once an input is successful, it stops. The tester, stops inputting until consensus is achieved on the first entry. So I feel like I'm close to passing this test. I have to say, I'm feeling it. I'm reliably now getting the same behavior, which is suggesting that followers are not committing. So the whole input, write, commit, output phase, the followers seem to not be committing. But there are also, there is stability. There's no crazy shit happening with new elections all the time. And all the writes are successfully happening. Everyone has the same log. So it's like there has been a definite improvement here. I have to say there's been a definite improvement. And with that, I'm leaving it for today. Go push. Whoops, sorry, git push. Go push. Next session is going to be basically when I said it was. I'm happy to leave it that way. Friday at 9 p.m. So this is tomorrow at 9 p.m. Just 24 hours later than the current session. And I want to try to get them back into the morning, but my sleeping's not good enough at the moment. So yeah, I'm just going to leave it at that. I'm going to push on and, I'm getting close. I'm getting close to passing the first test out of 7 of Part B. I think. I've made some changes. Whatever. We'll discuss it all in the next session. For now, I'll just leave it there and say we've definitely made some progress with Part B. And yeah, that's it. I'll be back on Friday. I'll check how many viewers I have. 1 viewer. Not bad, not bad. The reason I was checking was because I was wondering if I should do a quick summary of what I've done today. No reason why not. I can summarize that in 1 minute. And then I'll be out the door, pretty much. But yeah, you know, in my attempts to pass the test for part B, which is about logs actually working, the data getting through the algorithm from input to output. Everyone writes it down, everyone commits it, and then it gets output from the input. Sorry, speaking slightly confused. I'm trying to get that to happen, and the progress I've made is, you know, with the modifications I've done, I've removed a lot of context switching and unnecessary checks for the output phase, which was too demanding. So I've improved that. So now writes are consistently happening. There seems to not be any leader elections either, unnecessary leader elections. You can see append entries, but no vote request, which means that something is the leader, stably the leader, not getting challenged. And all the writes are happening, and the leader is also committing. Followers are not committing yet. And the output phase also seems to be happening very efficiently. As soon as the leader commits, like somewhere around here, the output is also done asynchronously. So yeah, once I resolve the follower committing, I think this test will pass, and then we move on. And this is only past test 1 out of 7, but cool. That's it. I'll be back 9 p.m. on Friday, tomorrow. 9 p.m. British Summer Time, UTC +1. And hopefully I'll just get to the end of test 1. That will already be a massive achievement. This is the hardest bit of distributed systems I've done so far. Not complete chaos, it's fairly controlled. It's just difficult to figure out how to optimize things when algorithms are running, you know, functions are running all the time in parallel, everywhere, concurrency, disaster. All good. See you then. See you Friday, 9 p.m.